Hello, my name is Andrei Kvapil, and today I'm going to show you how we implemented GPU support in Cozystack. But at first, let me explain what the Cozystack is. Actually, Cozystack is a cloud platform which allows you to simply transform your bare metal servers with no operating system installed into intelligent system based on Kubernetes with Kubernetes API for ordering managed services. These cloud systems have everything pre-configured like monitoring dashboard, alerts, and ready managed services. Cozystack provides ready infrastructure stack starting from the bottom layer, that means operating system layer and hardware layer, where we have Talos Linux. Talos Linux allows us to prepare reproducible environments because we can hard code kernel modules, kernel versions, and use them by the upper layers. In the bottom layer, we have operating system prepared, and on top of it, we run storage system with networking, virtualization. On top of this, we have operators, cluster API, monitoring system, and on the fourth layer, we say user layer, we have this beautiful dashboard where you can click and order any managed services you wanted. Just like any cloud, but on your own on-premise environment. Cozystack provides ready monitoring stack. We have really fast and reliable storage. We use Lean Store, which allows us to do almost bare metal performance. We have networking system based on KubeOVN and Cilium. Also, we have OEDC server based on Keycloak and virtualization system based on KubeVirt. This way you can run managed Kubernetes, managed databases, virtual machines, load balancers, and even S3 buckets. Our Kubernetes is fully functional. That means that our Kubernetes is like Kubernetes in every cloud. It has control plane separated. It supports persistent volumes. It supports load balancers and cluster autoscaling. Database as a service we do with full lifecycle management. That means that we use operators to manage every database lifecycle, to create new replicas, to configure replication, and to keep them alive. On top of this, on top of all of these operators, we actually created our own API server, which provides Kubernetes native entities based on Flux CD Helm charts. Actually, that allows you to define your applications very quickly. You can extend the platform with adding new services. And in the end, you will always have Kubernetes API objects. And if you want to create new Kubernetes objects, you don't have to recompile API server. You can actually just extend it with Helm charts and configure config map. So those resources will appear in your Kubernetes API. And then you can expose this API to your end users so they will be able to use those entities and communicate with them directly. Cozystack now is CNCF sandbox project. That means that now you have no vendor log, lower risks on changing licensing, and we have large community. Let's start with talking about tenant system. We actually consume Kubernetes namespaces, but we have design of well-known Linux systems. So we have tenant root, pretty similar to root user in Unix. And below this user, you can create new tenants, and every tenant have a domain name assigned, and every new tenant will get new domain name as subdomain to this domain. If we'll look more closer, we'll see that there is some specific services needed to run other managed services in our system. So by default, tenant root have etcd installed, monitoring hub, and ingress. We also have cvdfs, which provides S3 buckets. If you create new tenant, it can be created as any application. You can explicitly specify if you want to have separated isolation in terms of etcd, if you want to have separated etcd cluster or monitoring hub. to collect the metrics from your applications. And when you start deploying applications inside of this tenant namespace, they automatically consume those services from the tenants. If tenant have no specific isolation, for example, this blue tenant foo have no isolation by ingress, so Kubernetes cluster deployed here, it consumes upper tenant ingress. Thanks to this system, you can consume resources very smart. That means that you can have one monitoring system, let's say for tenant organization, and you can have isolation for your team members. By default, tenants have access, networking access from up to down, but from down to up, they have access only to these specific services needed to store the data. This way you can create, for example, one common Grafana and still have isolation between the tenants, but collect the metrics from those bottom tenants. That's actually it. Now let's switch to live demo. Here we have cluster installed. It already have configured ODC server, storage and networking. The first time we log in into Cozystack, we have some applications pre-installed. So we have tenant root application installed, and we have also monitoring, etcd and ingress. In case if you want to create a new application, you just switch to catalog and you can switch any application you want to. For example, you can deploy your own Kubernetes cluster, virtual machine, Postgres, Redis, or anything else. If you want to create new tenant, this is also a separated application which you can click and install. And here you can specify if you want to have to configure this tenant having separated isolation, for example, separated etcd cluster. In our case, I'm not going to do that. I'm going to create new tenant for myself. I will name it Kvaps, and I will have only isolation by the networking layer. Let's deploy it now. Now we can switch to applications. Let's refresh the page. And now we can see that a new tenant is deployed here. Now I switch to my tenant namespace and I can see that another default application is already deployed here. That's actually info application. This application needed just to get kubeconfig file. So you can get a kubeconfig file and give it to your tenant user. Let's switch to console. I can actually create kubeconfig. I will copy paste it right from the dashboard. You can see that it have already pre-configured endpoint to your server and already have ODC login for logging into your cluster. Now let's export environment variable to this kubeconfig file. And now let's check the connection. It will ask you to log in your web browser. I think I already logged in, so it will just get the token, and now we can use this kubeconfig file to access your cluster, to access your tenant namespace. This kubeconfig already configured to exactly tenant namespace you downloaded it from. So we can check if there are any pods running. There is nothing yet, but we can also check the nodes. In this cluster, I have 3 control plane nodes and 1 GPU node added for our tests. Those nodes actually deployed by Talos Linux. We have our own tool to configure Talos Linux itself. And before we start demonstration of GPU functionality, let me show how the virtual machines are work. So in case if you want to create new virtual machine, you can specify that you need a new virtual machine. Let's call it test. You can choose instance type. You can select the system you want to, and you can create the virtual machine itself. Then it will start deploying. Here it is. We can see the workload state. So for now, this virtual machine is going to be prepared. Let's check what is happening in our Kubernetes cluster. So we have KubeVirt virtual machine. We can see that it is provisioning. I can also check data volume, which is currently import in progress state. So we can take a look on this data volume. That actually will create persistent volume claim. Then it will start downloading the Ubuntu image. Let's take a look at the spec. You can see that there is a URL which is going to be downloaded and place it in our PVC. And now we can see that it is in progress. So after this persistent volume claim created, the image will be downloaded to it. It will also automatically convert it. If it is in YAML format, it will convert it into block device. And right after that, the virtual machine will start. Now we can see that our data volume get provisioned. Now let's check our virtual machine. It is in starting state. We can check because every virtual machine actually put KubeVirt working that way, that it runs YAML process inside of the pod. And after the virtual machine is created, we can use virtctl tool to attach console of this virtual machine and see what is happening inside. We can see that now this virtual machine is booted. So it will take some time to boot. And after this virtual machine is booted, you can actually connect to it through the SSH or using console or even VNC. So you can use VNC. It will open your VNC browser and show the state of the virtual machine as well. Okay. Now it is about to configure networking. After it's booted, we can try to log in, but we actually didn't specify any password, so it will not let us to go. We can disconnect. And now let's see how it looks like in terms of Cozystack API. So Cozystack API is actually a normal Kubernetes API. You can check API resources in Cozystack group. We'll see that there are a lot of resources like, you can see that there are a lot of resources like Postgres, virtual machine, disk, virtual machine, instance, such resources like Kafka, etcd, and stuff like that. So you can actually query those resources directly. For example, kubectl get virtual machines in apps.cozystack.io. It will show that there is virtual machine test is created. We can actually see what is inside. There is some spec, and we can save this virtual machine to YAML file and then remove status, some service fields, and now you can actually reuse this resource to create another virtual machines. Let's save it like this, and now we just want to create virtual machine with GPU. But before you start using GPU, you need to configure your cluster to using GPU. So now let's talk from perspective for cluster administrator. So you just get the node with GPU. And now we want to use GPUs from this node to create virtual machines and pass them through. In this case, the Cozystack installed by default, it has no GPU operator enabled. You need to enable it explicitly. In this way, you just edit Cozystack configuration file. This is common configuration file for Cozystack. You just need to enable this component by bundle enable option. And we just say GPU operator. After that, we can check namespaces. The new namespace will be created. I was installing GPU operator previously, so this namespace is still existing. We can check pods inside of it. Cozy GPU operator. There are no pods yet because this config map is getting reconciled every minute, so it will take time to create needed components inside. While we're waiting that, we need to also label this node with specific label, which will say to GPU operator that we will use VM pass-through mode for our GPUs. Yeah, and now we can see that GPU operator just deployed. It will also automatically discover the node we have. So it will create additional pods which will configure drivers to use this GPU. It will also take some time. Let me first show you how can you... Yeah, it will take some time. Let's watch for this. It creates actually the view manager, which will configure your driver, your GPU devices, be ready to pass through. After all the pods become ready, we can switch actually to start using this GPU. But before you can pass it through, you need to get information about this GPU device, so we need to get some information what exactly device is. For this we can just check the node in allocatable devices. You'll see this key value that our node have 4 GPU devices ready to consume. Before we start using them in virtual machines, you need also to configure KubeVirt itself. For this, you need to get exact information what the vendor ID and product ID it has. You have 2 methods here. The first method, if you use Talos Linux, you can ask Talos directly. In this way, you need to go to your configuration and send request to the node. We use Talm, but you can use also talosctl for this. We just use get devices to see all the devices of this node. There are so many devices. Let's filter them by NVIDIA. Here they are, 4 NVIDIA controllers in different PCI buses. We can even query specific device. The command line tool is pretty similar that Kubernetes has. So we can query it in YAML format, and we'll see that there is vendor ID and product ID. In case if you want to use another method, you can use Node Shell plugin to create shell exactly on this node. We use X mode. That means that it will not get exactly shell of the node because talents have no any bash or shell installed, but it will let us log in into the container. But this container should have all the access to the node. So for example, you can have access to the host system. But what we're interested here is PCI devices. Now we can switch to Cozystack documentation. We have operations, virtualization, GPU pass-through. And there is a command ls PCI. We can use it in here. The only thing we need to do is to install PCI utils. And in here we can have the same output like a PCI bus, vendor and device ID, and those 4 devices. The only thing you need to do now is to configure your KubeVirt. You can edit KubeVirt resource in Cozy KubeVirt namespace and add this configuration that KubeVirt can consume those devices. So this is resource name we get from the node, and this is PCI vendor notation we used from lspci command or from Talas output. After you added this section, your cluster is configured to use those devices. So now we can create another virtual machine. Previously we created this one. I'll show pre-configured another one. It's quite similar. The only thing I added here is cloud init configuration to have password, so I can log in into this virtual machine. And also I specified that I want to use this GPU, and I added my SSH key. Let's create this virtual machine. It should also be appeared in a Cozystack dashboard because it looks into the same API and it is still in deploying state. Let's check the console. We can check data volume. So we can see the pod importer. The data volume importer uses this pod to download the image and place it into persistent volume. We can see the process in data volumes. Let's wait until it finished. Yeah, now it seems done and the virtual machine should be starting. In KubeVirt, every virtual machine is actually pod. So we can get the pods. You can see that few virtual launcher pods are created. We can check the spec of this pod. Let's use edit for nice formatting. And in resources, it should have this resource allocated. That means that this pod is going to be created on virtual machine with this resource allocatable. So now this virtual machine will use this GPU. The virtual machine is already running, so we can connect to it using virtctl. Now we have a password set. we can use the same command for lspci. And we can see that there is GPU existing inside of the virtual machine. Let's try to consume it. So now let's use virtctl ssh command to get access to our virtual machine. Sometimes the SSH of virtctl works not well, so we can use local SSH and you'll get access to the virtual machine. So now we are going to install NVIDIA drivers. To have the opportunity to consume this GPU. So after driver get installed, you can use NVIDIA tool to detect the GPU inside of the virtual machine. You can see that now it is using NVIDIA A10 card. To test it, we will use GPU stat application. And now we can see that driver is installed and everything is working fine, so you can use your workload to consume this GPU. That's actually it, how it works inside of the virtual machines. In the latest version of Cozystack, we also introduced GPU support for Tenant Kubernetes clusters. Let me first explain you how Tenant Kubernetes clusters are working. At first we can get into catalog and we can install our Kubernetes cluster by specifying name for it. And this cluster has a configuration for node groups, so you can specify minimum replicas, maximum replicas, the amount of ephemeral storage, the roles for the nodes, and as well GPUs. At the beginning, I will not enable anything, so we will create simple Kubernetes cluster and wait until it gets deployed. You can see that it has workloads, it has 2 control plane pods and 0 workers. So we need to wait a little bit. We can also check the pods in our namespace. It is going to provision also cluster autoscaler, kubevirt controller manager, and CSI controller. To provision Kubernetes clusters, we use Kamaji. Kamaji has control plane resource, which is currently provisioning. It gets data store assigned, so it use etcd from tenant root. And now we can see that it started creating Kubernetes control plane. And after this control plane is created, the cluster autoscaler will take a look inside of this control plane and will automatically create a node group out of machine deployment. So for now we have single machine deployment which have no replicas assigned, but in a while they should start to be provisioned. Okay, cluster autoscaler is created. And now we can see that it have assigned 2 worker nodes to our node group, and we can check VMs. They also started to be provisioned automatically. Yeah, they become running. Now let's check what is inside of the our dashboard. We can see that control plane is ready and 2 worker nodes are created. To consume this Kubernetes cluster, you can download a tenant configuration file. To do this, you can download your secret admin save as kubeconfig for tenant cluster. You can see that now it go through our ingress, so it has the specific subdomain and also subdomain for tenant where it gets deployed. Let's use export to export our kubeconfig file and check what is happening inside. So we can see 2 ingress nodes created. That's actually worker nodes. And we have already some pods, some workloads running, actually Cilium, Seaside driver, Core DNS, and connectivity agent. So this way we can go back to our management cluster by switching back to the old kubeconfig file and get Kubernetes. We can see that Kubernetes test is get running. And let's check what is inside. Actually, the configuration we specified. Node groups of these instance types, max replicas 10, min replicas 0. So now let's create Kubernetes with GPU. We will go to the catalog, choose Kubernetes, click deploy, switch to YAML editor. And in here we have node groups configuration, so we can create additional node group. I'm going to call it MD1. I want exactly 1 replica without autoscaling. Also, we need to specify better instance type, because the smaller ones do not supported by GPU operator. And also I'm going to switch ephemeral storage to larger one. And in here you can specify GPU we specified for the virtual machine. So we can check what the allocatable devices our node has. That's exactly the thing you have to specify here. Also, we are going to enable cert manager, Jinx ingress, and GPU operator. That's probably it. Now we can click deploy. And Kubernetes is getting to be created. Inside of the console, we can see that tenant control plane from command G is going to be provisioned. It will take some time when it will generate kubeconfig file and data store. Yeah, now it gets data store, so we can check pods. It is still creating. Become to running, so we can get into the dashboard and download our kubeconfig file. Let's save it to kubeconfig GPU. And check the nodes. You can see that our cluster have no nodes yet. It already has some pods pending, but nodes are not started yet. So let's switch back to the management cluster and check how is it going. Here is MD1, our node with GPU, and MDO without GPU. Both are still in provisioning state. Okay, the VMs are running, so let's switch back to our cluster. They get created. and become ready. We can also check pods in other namespaces. We can see that GPU operator is going to be created and Nginx ingress. To access Nginx ingress, we can also update the configuration of our cluster by specifying additional host names we want to pass through into the cluster. I'm going to specify GPU dev5 infra Ænix org. So after we do this configuration for ingress Nginx add-on for this cluster, it will take all the traffic and pass through the main ingress controller. Inside of management cluster, you can see that new ingress is created for passing through all the traffic into Nginx ingress running inside of the tenant Kubernetes. It seems our ingress is not ready yet. One replica become ready, so we can check it with serial command, and it will report default backend. That's actually exactly this pod responding to our requests. We can also check the pods inside of the Cozy GPU operator namespace. We can see that a new daemon set is running. This daemon set is actually downloading GPU drivers and installing it into our virtual machine. This way it allows you to specify exact driver you want to. You can have open source driver, you can use proprietary one with different versions. NVIDIA GPU will automatically download specified versions and inject it into your kernel. You can see that there are NVIDIA drivers getting to be created in the node. We can also check the pods. And we need to have all the pods in this namespace in running state before we can continue. Okay, now it seems ready, so let's try to demonstrate how can we use it. To demonstrate the work of GPU operator inside of the tenant Kubernetes cluster, I'm going to use stable diffusion chart, which I downloaded from this repository. The only thing, it is slightly updated, so I was forced to change the model address because the old one is not accessible anymore. I have prepared values file where I also specified the host for the ingress and also enabled TLS and automatic certificates issued by Cert Manager. To make it working, I also need to create certificate issuers for Let's Encrypt. And now let's install the Helm chart with Helm install command and with our values files. It will actually create stateful set, pod and PVC. So the good question, where the data is stored, actually we use persistent volume claim created inside of the management cluster. It gets volumes provisioned and pass it through into tenant Kubernetes cluster. Let's check how it looks like. For this we need to switch back to the management Kubernetes cluster. We can see that it has persistent volume provisioned for the tenant Kubernetes cluster and the hot plug volume created. This is actually pod. It uses for attaching this persistent volume claim, and it is always running in the same node where the virtual machine is running. Then KubeVirt has its own logic to pass through this device directly into the virtual machine. So let's switch back to the GPU cluster and check the pods. We can describe to see the state. We can see that it is already finished the init container job. Let's check the logs. In this init container, it downloads models and places into the persistent volume created for this virtual machine, for this pod. And now it is about to pull this image. It is quite thick, so we can wait for a while until this image gets pulled. Yeah, now it seems running. So we can access it through our web browser. And here it is. We have stable diffusion running on our Cozystack Tenant Kubernetes cluster. And let's try to test it. We can write a prompt. We can see some pictures. All right, doc watching terminal. Let's try train to the future. Seems better. Just nature. Beautiful pictures. Alright, that's actually all I wanted to show you. You can use Cozystack to run fully functional Kubernetes clusters, virtual machines, and as well databases. Now you can also use GPU workloads in your clusters, and here is a practical example. Please feel free to join our community channels. We have Telegram group and Slack channel in official Kubernetes Slack. And if you're interested in enterprise support, or if you want to sponsor some features, feel free to contact Ænix. Thank you and bye.